Hi everyone, in this video you're looking at simplifying algebraic expressions and those involving the fractions. So if you're a bit stuck, I'm going to put a link in the comments below. Yeah, I just did that. To one of my Year 7 videos about how to do addition, subtraction, multiplication and division with fractions. So I'm going to be zipping through it in regards to that process. But I want you to remember that you've got to apply your algebraic processes. So things like terms, collecting like terms, or even like how you deal with the variables, okay? Expanding brackets and so forth. All right, so that covers simplifying. Remember, an expression doesn't have an equal sign in it, so that's what we're doing, and we're just trying to find a way that's easy to write. So we're kind of making it simpler. So in mathematics, generally, instead of writing 14 out of 28, we can just write 1/2, and it's a lot simpler. So that's what we are looking for in our expressions. So basic operations: add, plus, subtract, divide. Oh, sorry, add, subtract, multiply, divide. And your fractions, numerator, denominator, and you can have equivalent fractions 2n, 2d. They're still the same, aren't they? Because if we divide those, we end up with n over d again. All right, and like terms. With your like terms, so if you think about it, if we have 2 apples plus 3 bananas, we can't say that it is 5 banapples. It's actually that they are not like terms. Apples and bananas represent 2 different things. So it's the same with other variables. You say 2 supercharged apples and 2 regular apples. It does not equal 4 apple 3. So be very mindful. Again, if you need to go back and have a look, the Year 7 videos that I've done up or on like terms will be able to help you out there. Okay, so without further ado, let's get straight on into it. Addition and subtraction, your denominator has to be the same. So in this case here, I'm going to find a common denominator, and it is straight away, because I can do my timetables, it's going to be 6. So I need to take these numbers and multiply them by another number to give me 6. So in this case it's 2, and this one is 3. And if you want to, someone might say to you, but hey, if I just multiply those 2 numbers together, like that'll give me a common multiple. That's cool, you can do that, there's nothing wrong with that. It just means that you might have to simplify it more when you get later on down the track. So what I do at the bottom must do the top. So 2 times 3 is 6. 2 times 2, so 2x, times 2 is 4x minus 3x over 6. Now they've got the same denominator. I can treat them like I do a subtraction. So 4 minus 3, or 4x minus 3 gives us 1x over 6. Next one, again, same thing. Even though there is a whole term here, there are 2 terms in the numerator, we still treat that exactly the same that we do with the previous one. These 2 need to be the same. So if you wanted to, yes, you could just multiply these 2 sides. So, multiply this side by 4, top and bottom, multiply this side by 6, top and bottom. All good, happy days. I'm not going to begrudge you of doing that. However, I would encourage you to find the lowest common multiple. And for these 2 numbers, it's 12. So with that, it means that I am looking to take my 6 and multiply it by 2. What I do to the bottom, I'm going to do to the top. But this time, remember, I'm multiplying everything by 2. So I just put brackets around the front. And in this case here, it's 3. 4 times 3 is 12. And again, number on the front, and that'll help us out. So Oprah Winfrey, everyone gets a 2. 2x plus 2, and this becomes 12, plus 3x, again, another Oprah Winfrey, and 3 times 4 is 12 over 12. Leave the 12s as they are, collect up like terms, 3x plus 2x plus 2 plus 12, and that is going to give us, look at that, 5x plus 14 over 12. I can't actually simplify here. I thought I could, but I can't because I was looking at common numbers. So if you were going to simplify, you would have to actually factorize this one first and then simplify. But there aren't any common factors in your top line. So if you're stuck with that, there'll be another video later on. Anyway, so I want you to now pause the video. This is the important bit, your turn. Have a go at these questions here, changing those to a common denominator so that you can minus or plus, so subtract or add your numerators to give you an answer. Don't forget to simplify if possible. Okay, let's go on. Pausing and now resuming. So multiplication. Multiplication is, if you want, cancel out your common factors first and then multiply the numerators then denominators. I just do numerators and denominators because it's like top to bottom. Yeah, bit of a logic. Okay, so you, in this case here, when you cancel out common factors, there's only two ways you can do this. It's this direction, so a top and bottom, or a top and bottom on the other fraction, or it's going this way. So the top one from here and the bottom one here, or the top one from here and the bottom one from here. You cannot pick and choose what you like. It has to be balanced. So I'm just going to do this one as it is. So 5 times 6 is 30 YZ. 3 times 7 is 21 X, Y. Now I'm looking for common factors to simplify. There's a Y, there's a Y. So remember, the reason what we're doing here is Y is also the same as saying 1. Because if I've got several pieces in a full pizza, it's going to be one whole pizza. Yep. Okay, so those Y's cancel each other out. 30 and 21 have a common factor of 7, so I'm going to divide them both by 7. That leaves us with, with 3. That gives us 10 and 7. So my answer is going to be 10z divided by 7x. And voila, that is your simplified expression. Notice how there's no other equal sign, it's just this working down systematically. All right, this one here. Ooh, okay, you're really like, what is going on here? You might be tempted, because that's what I was first, to expand the brackets, then do all these together, so multiply them all together, and then expand, and then multiply, so distribute that 2x over all of this. You're going to end up with some really complicated numbers, and it's going to hurt your head a little bit. So it's best to cancel out beforehand. And what we mean by cancel out, I'll show up here. So 5y times 6z, 7y, and 3x. What this means is that you take your numbers and you look for something that is a common factor in either this direction, so that's a nope, nope, this way, nope, this way, aha, yes. So 3 is common, so 3 divided by 3 is 1, 6 divided by 3 is 2. So what I'm left with is 2z and 1x. So 5 times 2 is 10. Wait there. Oops. My bad. If you have a look back up here, also the y is a common factor on these sides. So 10z, and that's the top one, and x times 7, 7x. Look at that. There we go, same answer, hey? Looky. So using that cancel out principle, we have a look here. Think of it like this is a set, and if we have a look over here, this set matches, and we can immediately cancel them out. There's an imaginary one there. Over this way, we've got the x's, so they cancel out, and then what you're left with then is going to be 2 times 1 is already 1, and you are left with 2x minus 3, and that is your answer. That's it. How simple. So you're going to multiply these guys, pause the video, do the questions. If you don't feel comfortable immediately cancelling out. There's nothing wrong with doing that. You just have big numbers, so it can be a little bit tricky to work with. But apart from that, though, there's nothing wrong with it. It's okay. Like to be honest, I still do it, and it's because I just always forget to cancel out things. So don't be bad. Don't feel ashamed about that. All right, algebraic fractions. So just like doing fractions, but there's just an algebraic component in it. So here we go. You flip or reciprocal of the second fraction. So if a whole number is its reciprocal equals 1/2. If the number is 1/2, its reciprocal equals 2/1. But we don't write that. We have some invisible mass happening here, and it's just 2. So in this case here, we take our first fraction, write it as it is, change that sign to a multiplication, and we flip this 9y 4x. I do a really bad job of explaining this y on first principles, so there's some really cool videos out there. So if you're really curious and you want to know why we flip that second one, it's go find those and see if you can do a better job of explaining it to people than I can. So looking at my numerators, 3 times 9 is 27xy squared. Make that a bit clearer. 2 times 4 is 8x. Cancelling things out, bow. The answer is going to be 27y squared over 8. And that is that. All right. Cool. This one here, again, a little bit tricky, but if you have a look at it, we're still going to flip the second one. So we'll do that first. 4x plus 1, 3x minus 5 times x plus 1, x minus 7. So if we have a look at these terms, oh, the one's been missed. Oh dear. If we have a look this way, we can cancel out those two. Then we can, I'm just going to move that up a little bit. And depending on who you are, I like to call it FOIL just because that helps me remind me of which ones to do first. But you can use whatever mnemonic or memory aid that assists you. So first 3x squared. So remember, everything's being multiplied. So 3 times 7 is negative 21x. Then that was the first, the outers, the inners, minus 5x. And then the last, positive 35. Collecting like terms, it's negative 26x plus 35. That is, that's the bottom line. So sorry, I've run out of space there. It actually equals simplified 3x squared minus 26x plus 35. Yeah, cool. So let's have a look here. You're now going to take, you probably won't get one of this complexity here, but we will do some in class or if I have the homework. You need to pause the video and do the basic divisions. I'm sorry, this is a bit of a long video. It's just, I wanted to keep everything in one very short and sweet video. All right. Link down below if you've forgotten how to do fractions in general and your basic operations. All right. Stay awesome. Bye.